Alrighty, the next one is from homework number 11, confidence interval part 2, question number 8. Alright, let's take a look. A survey asked if the husband in a family wants children, but the wife decides that she does not want any children. Is it all right for the wife to refuse to have children? What a question, huh? Alright, so they said of 737 subjects, 551 of them said yes. Okay, so what are we doing? We're creating a 99% confidence interval for, look at this keyword for me, okay? Population proportion, okay? Proportion. So if you're trying to create a population confidence interval to capture the population proportion, we're going to just delete all this data. I was doing other homework problem. Then this is where you're going to go, okay? Go to stat, go to proportion stats for me, proportion stats. And we got one sample, right? We got a sample of 737 subjects. So click on one sample with summary. We have summary given. They told us that out of 737 people, 551 of them said yes. So go ahead and click on summary. And then tell them that the number of success, and then the number of success over here is the number of people who said yes, which is 551. And then the number of observation is 737. Now we want to create a confidence interval for P, and the level that we want is 99% confidence. So click on confidence interval for P and change the level to 0.99 for me. And then click on compute. We got it. Here we go. Here's the confidence interval. The lower limit is from 0.70. Oh, wow. Really? Okay. I mean, that's good, right? Because if husband wants family and wife doesn't want any children, is it okay for the wife to refuse to have children? Yeah. If she doesn't want children, I mean, what is he going to do, right? All right, let's see. So, the lower limit is 0.7064. They want it pretty accurate, 4 decimal places, so 0.7064. So the lower limit is about like 70%, 71%, and the upper limit is about 0.7888. I'm just copying these lower limit and the upper limit over here. Be careful with rounding, and then check answer. That is it. Now, let's talk about the conclusion. Let's talk about this. Now, notice this lower limit is 70. So we are at least 71%, but lower than about 79%. All of the population, we're expecting them to say, yes, it's okay for the wife to refuse to have children. So let's say, can you conclude that the population proportion exceeds 75%? Now let's take a look though. 75 is definitely in this interval, right? 75% is in this interval because it goes from 71% to 79% rounded up. But the fact is, I mean, notice it also goes below 75%, right? 71%, 72%, 73, and 74 are all included in this interval. So, be sure, can we go ahead and conclude that it exceeds 75%? And parts of it exceeded, but also goes below it. So, no, we cannot conclude it. We cannot conclude that the population proportion exceeds 75% because 75 is above the lowest believable value. No. Which one are we talking about? Let me read this. No, we cannot conclude the population proportion exceeds 75% because 75% is below the lowest believable value. No, it is above. It's above the... So, suppose that you got an interval, okay? What if you got an interval? Let me see if I can try to type up an interval over here. Say that you got an interval like this, like 78% to 83%. Say that you got an interval that looks like this. Then we get to say, oh yes, it's going to be over 75%. Or if you get something like 75 to 83, you notice 75 or yes, so if your interval is entirely greater than or equal to this number that they were interested in, then we get to say yes. We can conclude that the population proportion exceeds 75. But our interval over there that we just got was from 71 to 79. So although some of it goes over 75, 71 is a plausible answer. 72 is a plausible answer. So we're not going to know it. So the answer is because 75 is above the lowest believable value. So we're going to go ahead and say that is our answer. And without doing any calculation, they said explain whether the interval in A would be wider or narrower than 95% confidence interval for the population proportion who would say yes. Now, this is a type of question that I asked on data assignment 4. Now, remember we talked about how the confidence level and the margin of error are related, right? So if you want to be a little less confident, now this one was 99% confident that we calculated, but if you want to go down on the confidence level a little bit, you're going to be a little less confident, but that means your margin of error will actually be a little bit smaller. Let's say. Now, if you're not sure, you can definitely go ahead and do another confidence interval. So like, why not? You can do it, but the relationship goes like this. Okay, let me go ahead and type this up. As the confidence level decreases, and that's what's going on, right? They are decreasing the confidence level from 99 to 95. The margin of error will decrease. Okay, margin of error will decrease. Why? Because based on the confidence level, we pick our critical z value, right? Critical z value. And the critical z number gets bigger as confidence level increase, and the critical z value will decrease as a confidence level decrease. So, and that z value, the critical z score, z value, is the number that we multiply to the standard error to get the margin of error. So, the smaller number that we multiply, the smaller the margin of error we will have. So therefore, as the margin of error decrease, what that means is our confidence interval will be a little bit more accurate. It will be more, it will be narrower. We'll be able to have a smaller range, and that's a little more accurate, right? So 99% confidence interval would be wider than the 99% confidence interval because of the margin of error. Okay, so that is how you would do this problem. All right, so definitely try the similar problem, okay?